Welcome to day 2 of polynomial graphs. This is lesson 17. And again, I have the same warning that our previous one had, that this lesson is a continuation of our hodgepodge of polynomial graphing. Remember, each title of the concepts matches the title of the skills in your Delta homework. So that is how you determine which part of your notes you're going to look at for the homework. So with that said and out of the way, let's finish our last set of notes for the semester. So our first concept is selecting the equation from the graph roots. So to determine the factored form of a polynomial's graph, we need to understand what the graph can tell us about the factors. We need to know two things from the graph. The first thing we need to know are the roots or the X-intercepts. So we can turn these into factors such as x plus a number or x minus a number, depending on the X-intercept. Now, we're going to practice this. So we want to write the following X-intercepts as factors. So we have 3, -5, and 0. The big thing for this is opposites attach to the x. And what I mean by that is we're going to take these X-intercepts and they are going to get parentheses with an x. And then this is what I mean, opposites attached to the x. So the opposite of +3 is -3. The opposite of -5 is +5. The opposite of 0, well, is just 0. So in actuality, this guy right here is just going to stay x. So when we're going from intercepts to factors, they become opposite when put back into the parentheses attaching to the x. The next thing we have to talk about is the characteristics of our graph. The characteristic of the roots will also determine how many of those factors are at that root. So there are two characteristics you guys need to pay attention to. There is what we call the bounce. So this means that the function bounces off the x-axis. A bounce means there are two of the same factor at that x-intercept. And then we have what we call a through. The function goes through the x-axis. A through means there is only one factor at that x-intercept. So now that we have how to turn our x-intercepts into factors and identifying our characteristics, let's look at a graph and match it to an equation. All right, so this first one, nice and easy. So what you're first going to do is you're going to identify your x-intercepts. Here, we only have one x-intercept at -5. Then you're going to write that x-intercept -5 as a factor. So x minus 5, as a factor, we go opposite, x plus 5. Then we take a look at the characteristic. This is what I call a bounce. It bounces off the x-axis. You can see there's a bounce. So that means there's going to be two x plus 5s here. So x plus 5, x plus 5. Since there are no more x-intercepts, we're done. So now we just have to match what we just did from our multiple choice. And as you can see, it was our first option. So that is what we're doing here. So let's look at our next one. Again, we start by identifying our x-intercepts. So we have two x-intercepts. So we're going to have two different factors. Let's start with this one over here. This is what we call the through. It goes through the x-axis. So at this point, x, it's at positive 1, so we take the opposite, minus 1. And since it is a through, there is only one of them. Then we come over here. This one is a bounce. It's just bouncing upside down, but it's still a bounce. It's bouncing off of the x-axis. So let's write, so we know there's going to be two of them here. So we have x, this is -3, so the opposite is +3. And there's two of them. Now, something I didn't mention in the other example is there's another way we can write this. Remember, when we have two of the same thing, we can condense them down with a squared. So these mean the same thing. So what we're looking for is a function that has x plus 3 squared multiplied by x minus 1. So let's look at our options. Here we have x plus 1 and x minus 3 squared. That doesn't match, so it's not our first one. Here we have x minus 1 squared. Well, we know since x minus 1 is at a through, it only has one of them, so it can't be that one. Here we have x minus 1, good, there's only one of them. And then x plus 3 squared, that matches what we have, so that is our option. So that is what you're doing to match a graph to an equation in factored form.